Yarden Shafir telling us about Intel CET and how to stop being scared of French baking. So we had some French cooking. Now we're moving on to French baking.
Hey, thank you. Yeah, that was a really good order for the talks, because French baking is pretty different from French cooking. I'm going to talk about that. Let me just share my slides. So we're going to talk about two very different things. Intel CET, which is a new security feature on the recent Intel processors that are out since the last few months. And then we're going to talk about French baking and how to take something that seems really complicated and sounds really complicated and make it really, really easy and creative and fun, and make people think like you put way more effort into your baking than you actually did. So we'll start with Intel CET. First, who I am, my name is Yarden. I'm a software engineer at CrowdStrike, and I teach Windows internals classes, mostly together with Alice Nesco in conferences and stuff. I used to be a pastry chef, and now I'm a hobbyist. And pre-COVID, I also used to be a circus artist, and hopefully will be again. So we'll start with the security-related topic, which is Intel CET. That's a processor feature that Intel added into their newest Tiger Lake processors, which is meant completely for security purposes, because there is a very common, relatively well-known exploitation technique called ROP, return-oriented programming, which is a method to hijack the execution of application. If you can, of an application of process, if you can't allocate and run your own code in it, it basically uses existing instructions in the process to create your own shell code without allocating and writing one. There are a few different ways of doing that. ROP is one of them, by overriding a return address, because when a call instruction happens, the return address is being pushed into a stack. So if you as an attacker have control of the stack through stack corruption or anything similar to that, you can override the return address and when the function returns, it will jump to whichever address you put there, which once you can control, you can use your stack corruption to build your own shell code. Other ways are, for example, overriding a function pointer in a function table. So a call instruction will call the address you put in there instead of the address that was originally there. That's something that's handled by mostly through software with CFG or the newer XFG. But ROP is something that cannot be handled through software. Microsoft did try to do that. It didn't really work, so they got rid of that. It was called RFG for a while. But now we can have a hardware-based solution for that. And because it's a hardware-based solution, it's not as vulnerable to race conditions or to other things that software-based solutions have. The way it works is it adds a second stack. There is the normal thread stack where arguments go, where return addresses go, the one that the thread uses when it runs. But CET adds a second thing called a shadow stack. That's a stack that the process or thread itself is not supposed to be using, and the only thing it has is return addresses. Whenever a call instruction happens, the return address gets pushed into the normal thread stack, but it also gets pushed by the processor into the shadow stack. And the shadow stack is protected memory. Thread doesn't know where it is. It's not writable, it's not modifiable. You can't tamper with it, you can't corrupt it the same way you can't corrupt the normal stack. And then when the function returns, it reads the it reads the return address from normal stack, but the processor also reads the return address from the shadow stack, and it compares them. And if it's not the same return address, there will be an exception and the process could crash. That depends on the operating system. But generally, CET can be used. It does implement a few other things, not only a shadow stack, not only a ROP mitigation. It also allows for forward edge mitigations and a couple other stuff. But right now, operating systems don't implement that. The main thing that it's used for is as mitigation to ROP. And because I like diagrams, we'll see here that what I'm going to show now is a normal flow. We have a call instruction, and the return address is being pushed into both stacks. And it is the same return address. And now we can imagine the function running, all sorts of things happen, and then the function returns with a ret instruction. Now the ret instruction reads the return address from both of the stacks, compares them. In this case, they're both the same. So we jump to the address and we keep running as expected. What happens if there's an exploit that corrupts the stack is a call instruction happened, pushed both return addresses, but while the function is running, this exploit comes in and corrupts the stack. So this is a relatively simplified version. Usually you wouldn't just corrupt the return address, you usually corrupt a lot more of the stack to, for example, corrupt multiple return addresses or control variables or have some more things. But in this case, you just corrupt the return address. And now when the function returns, if we didn't have CET, it would just jump into the fake return address given our exploit code execution. But in this case, it reads both addresses. Since they're not the same, and it throws an exception. Now, throwing an exception doesn't necessarily mean that the process is going to crash. An exception is just something that the processor throws and has absolutely no idea what's going to happen to it. And the operating system is supposed to catch those exceptions and decide what to do with them. The system doesn't necessarily crash on every exception. There are a lot of different types of exceptions. And you can even use, for most exceptions, or for some of them, you can even use try catch or try except, depending on what language you're writing in, to ignore your exceptions yourselves. In our case, the operating system needs to catch that exception. And what Windows chooses to do is what it does with a lot of different mitigations. It has several options. It can choose to crash the process, because if we got a CT exception, something bad probably happened, an exploit overwrote our stack. We don't really know how to recover from that. And then it will crash the process. But that's a very simplistic view of it. And for anyone who's been in security for more than a few years, I've had more than enough cases of saying, oh, this is definitely what's going to happen. This is definitely a malicious thing. We want to detect that always. And then you ship your product, it runs on exactly 3 customer machines, and then you get an angry phone call from a customer saying, no, our IT has a script that does exactly that. We're injecting code into LSAS on purpose. We want to do that. Why are you blocking our PowerShell script? So you can't really crash every process that has a CT violation, because Microsoft is a big believer in backward compatibility. And there are a lot of things that actually use ROP as a semi-legitimate technique. Some security products use it as part of their code injection, because code injection is messy. Even some Microsoft products have built-in ROP for all sorts of different reasons. So you can't just enable that mitigation and crash everything, because it will start crashing a whole lot of things that use it as a feature. And you don't actually want to start crashing everything. So Windows has Windows added compilation flag, like it does with most mitigations. This compilation flag is /CET compat, meaning CET compatible. And what it actually means is, hey, I am building this application knowing that it is compatible with CET. I know that my application is not using ROP as a feature. There is no reason you will see this application ROPing anything. And if you do, I want it to crash because this is not supposed to happen, so something bad happened. So when you build your new applications, please do build them with /CET compat. And if you can't do that because your application uses ROP as a feature, I recommend to stop using that before Microsoft starts enforcing this in, I don't know, 10 years or so. So you've got some time. So Windows will, for now, only crash applications running built with CET compat, because otherwise you can't really know. But what it will do is, if your application is not built with CET compat, and of course that all only happens if you're running with a CET compatible processor and operating systems, which none of you probably do because it's only been shipped like 2 months ago. But if you're running with CET compatible processor and operating system, and your application ROPed, but it is not built with CET compat, Windows won't completely ignore it, but it won't crash your process either. Instead, it's going to log that into the Windows event viewer through an W event. Now, this is what it looks like. For anyone not familiar with the Windows event viewer, it's very useful for forensics, for finding out what's happening in the machine, what happened, what could have caused a crash or security risk. And it has a few different channels, CET errors, errors and warnings. Warnings meaning the process did not crash, errors mean it did. So they're both logged into a place called Microsoft Windows Security Mitigations that has user mode and kernel mode, and CET goes into kernel mode. So in this case, what we're seeing here is an application, some random application that was running on my machine that is not built as CET compatible, but did have a CET violation, which is it would have been blocked from setting context. Now that doesn't mean it dropped. It doesn't mean the return addresses didn't match. I'll talk about what this warning means in a minute, but it would have been blocked, but it didn't because it's not built as CET compatible. So we don't know that it is using the same assumptions we do. And obviously in this case, it isn't, because this was not an exploit. This is just a completely legitimate application that does something that Windows doesn't currently agree with. Second case is an application that was built with CET compatibility, a part of VS Code, and it has encountered a shadow stack return address mismatch. And you can see here the process will be terminated. So that's what happens if Windows decides that, no, we really do want to crash this application. We're not okay with what's happening here. We don't think this is a legitimate case that's just like incompatible. We really do want to crash it. And this is a classic CET crash because of a shadow stack return address mismatch, meaning the address on the regular stack and the address on the shadow stack are not the same. But I want to go back to the previous case for a second, because here we don't see a return address mismatch. We see would have been blocked from setting context. Because Microsoft said, well, if we have that shadow stack and we have that capability, there are a lot of different ways of hijacking the execution of a process. Yes, you can overwrite function pointer, which CFG handles. You can overwrite a return address, which is the basic usage of CET, but you can also do things like calling set thread context, which lets you set the values for all the registers of a thread. For example, it's a stack pointer or it's instruction pointer. When you control those, you can control what the thread is going to do. You can tell it what code it's going to run, what part of the stack it's going to call. Another way is through exception handling, because when an exception is thrown inside of a process, it goes into the process exception handler. So if you can control the address of the exception handler and give it a fake one, well, you control what the process is running. So Windows added a few more CET-related checks for set thread context, for exception handling, for unwinding through continue. And it's a pretty complicated mechanism, all implemented inside the Windows kernel. But if you have a CET compatible processor, if you're one of the 5 lucky people who have a matching computer yet, then you can open your event viewer and you can see all of those warnings, even if you did not enable CET for your applications. All you need to do is to set CET to basic mode through the registry, and then you will get all of those warnings and you will see what would have been blocked, what would have been terminated, what is acting funny. And you'll see quite a lot of Microsoft applications there because .NET is not yet supported for CET. So for example, PowerShell is incompatible with CET, Visual Studio, a whole lot of things for now. And you'll see some interesting things. Things with Event Viewer uses ETW. So everything that you see in Event Viewer, you can also get through ETW events. So if you have a security product that wants to take advantage of CET, you can register for the ETW channels, get all the CET warnings, and try to decide for yourselves if it's just an old incompatible application, or if it's malicious, or if it's a piece of malicious code trying to take over a legitimate app. Like the last thing I'm gonna say about CET is that all I've been talking about for now is user mode CET for user mode applications, because that's what's been shipped for now on Windows. There are plans for kernel mode CET, which will probably be shipped sometime towards the end of the year or early next year, depending on Microsoft's schedule. But for now, it's only relevant for user mode applications. I can talk about CET for like another 2 hours. Alex Unescu and I wrote, I don't know, 7,000 word paper on it, which only covers part of it. But I only have 20 minutes for this part, so we'll move on to the non-infosec thing, which I can talk way more about, which is cookies. Like I said, I used to be a pastry chef. I studied French patisserie for a while. I worked in it for a little bit, and then I decided to just make it into a hobby. And as a hobby, it's actually way more fun because you get to experiment, you get to do all sorts of fun things, you get to discover what you can and can't do. And unlike French cooking or any kind of cooking, actually, baking to me is a lot more of a science. That doesn't mean that it's not creative and fun experimental, but it is very much a science. And I actually love that because once you learn the science, you learn what is set in stone and what you can play with and change and in what ways. And you get to do all sorts of really, really, really cool things. And in this part, I'll talk about one very basic part of French patisserie, which is butter cookies. Those little round butter flavored cookies that are always covered in sugar and made out of pretty much butter and flour. They're very, very, very simple. They're easy to make. Every coffee shop has them, and they're awesome, and they're one of my favorite things to make. And the reason they're one of my favorite things to make is, as simple as they are, you can do a million different versions of them. You can make them into different flavors. You can add different things to them, or you can make them different colors with no food coloring. And when you have people coming over in 2 hours and you've got nothing at home and you completely forgot to make something, but you still want to do something cool, you can use one mixer bowl, make 4 different kinds of butter cookies that all look and taste completely different, and seem like you made a huge effort and started making things 2 days in advance, and like you're such a cool baker when you use one dish in one recipe. So there are 2 principles to making butter cookies. Once you have those 2, you can do anything with them. The first one is the ratio of ingredients. The only 2 ingredients that matter in butter cookies are butter and flour. The sugar is only there for flavor. Egg is helpful to keep things together a little bit, but it's not necessary. Salt, cocoa powder, vanilla, all of that is just for flavor. The only 2 ingredients that matter are butter and flour. And for butter cookies to work, you need to use a ratio of at least 1 to 2, meaning the weight of butter has to be at least 50% the weight of flour. If you're going to use 100 grams of flour, you should use at least 50 grams of butter. That's the bare minimum. You can go as high as 1 to 1 if you'd like. I like using 2 to 3. Meaning for 100 grams of flour, I would use around 65, 70 grams of butter. That's individual. It also depends on exactly what butter and what flour you're using, which do change a bit between brands and between countries. When I say butter, I mean butter that has at least 82% fat. A lot of the common butter you'll find in supermarkets is sort of fake butter. It has 80% fat. I've seen as low as 75%, which I don't think is even legally allowed to be called butter in France. So you should look at that. The more fat percentage do you have, the more buttery flavor you're going to have. And also, you can keep to the original ratio. If your butter percentage goes lower, it will change things up a bit. But the cool thing is when you understand that butter is simply 82% fat and around 80% liquid, and a really, really, really small amount of protein and some other stuff, you don't necessarily have to use butter. You can replace it with other things. Now, for butter cookies to be successful, you need fat that is not liquid. You need a kind of oil or fat that is solid in room temperature. So you can't use olive oil, you can't use canola oil because they're liquid. But if you don't want to use dairy for whatever reason, like I'm Jewish, my family's religious, we can't have dairy after meat. So when I need to make desserts for my family, I can't use butter for meaty dinners. So you can replace that with things like coconut oil. Coconut oil is solid in room temperature. So you can replace the fat part of butter with coconut oil and the liquid with water, milk, coconut milk, orange juice, coffee, your favorite bourbon, anything. And again, flour is white wheat flour, but you can experiment and replace it with any other kind of flour, like gluten-free flour if you don't eat gluten. This is the only thing that matters. You want to put those 2 things, your butter or different fat and flour, into a mixer or food processor, process them together and get dough. It's not going to be especially tasty dough because it's not going to have much of a flavor. You don't have sugar in it. You don't have anything else. but it is going to be dough. Then usually to keep it together a little bit better, you want to add a bit of either fat or liquid. It can be an egg yolk, a bit of milk, a bit of water, a really tiny amount. But that's all you need for the dough. Now, the second thing is you don't want just any dough. You want that unique texture that butter cookies have. And that texture is kind of crumbly. It crumbles everywhere. It breaks when you take a bite out of it. If you compare it, for example, with bread, bread doesn't do that. Bread is a lot more, the dough is more elastic. The dough of bread is a lot more chewy. You don't want to have the same texture as bread in your butter cookies. But they're both pretty much made of, similar ingredients. So here the difference is how you process it. Because that elastic, chewy texture that we get in bread, that comes from gluten. And gluten, when we talk about gluten, people think, people talk about flour having gluten. That's true, but that's not really accurate. Flour has a potential for gluten. What flour does have is two other proteins called gliadin and glutenin, which when they meet in the presence of water, they turn into gluten. Gluten is what gives us this elastic, stretchy, chewy texture, which we love in bread, but we don't love in butter cookies. And the way to create gluten is to take flour, add water to it, and just process it, mix it, knead it for as long as possible to make sure those two proteins will meet, will have the largest potential of meeting and creating gluten and creating sort of a net that traps water and air inside the dough. Now, because we don't want that in butter cookies, what we want to do is to process the dough as little as possible, so the potential for creating gluten will be as low as possible. Of course, it will still create gluten, because that just happens, but we'll have less of it than we have in bread. So we want to give it as little time as possible to create, so we can have that crumbly texture. Now, the other thing is that one more way to prevent gluten from being created is with oil. When you add oil into the flour and water mixture, the fat wraps around those two proteins, and it doesn't really stop them from combining, but it makes the process a lot slower. So when we add a whole lot of oil and fat in the form of butter into our flour, then we'll get less gluten. It also means if you're trying to make bread and you're making, for example, a brioche, you would want to add the butter a lot later. So you could first create all your gluten and then add butter, so you don't prevent it from being created. But in our case, it's actually good because we don't want a lot of gluten in our dough. So that's part of what makes butter cookies awesome. By design, you need to work them really, really, really little. You want to throw all your ingredients into a food processor, work it just until you get something that can barely pass as a ball of dough. Add that little bit of oil or liquid to make it stick together, and then wrap it in nylon or whatever, and put it in the fridge or the freezer. It doesn't matter too much. If you want to make it immediately, you'd want to wrap it and put it in the fridge to, for example, roll it, make all these shapes with your cookie cutters, which is awesome. The industrial way to do that, which is also the lazy person's way and my way, is to make it into a roll, wrap it in nylon, stick it in the freezer And then once you want to bake it, you take your frozen roll of cookie dough, you cut it into cookie shapes, and you bake it. It's really, really, really easy. You only get one shape this way, little round little circles. If you're feeling creative, you can try to make your roll shaped like a square or a triangle, and then you get square triangle cookies. But that's about it. You get one shape, but it's really easy and really, really, really not messy. So that's for the science part. You put everything together, right ratios, process it as little as possible, and stick it in the fridge or freezer until you want to bake it. It's easy enough. But this way you only get one kind of cookie, and we didn't even talk about sugar or anything that gives it an actual flavor. But here's the coolest thing. Because these two principles are all you need to get successful cookies, you can do pretty much anything to give it flavor. You can add a little bit of sugar to get those standard light butter cookies. You can do anything else as long as you know what kind of material you're using. If you're using something that is dry and close to flour, like cocoa powder or almond flour or hazelnut flour or anything that is kind of powdery, all you need to do is replace a little bit of the flour with it, usually 10 to 15%. If you're putting cocoa powder, replace 10 to 15% of the flour with cocoa powder and you have chocolate cookies. If you want to add anything that is liquid, like coffee or mashed strawberries, fruit are counted as liquid. Whatever you do with them, they count as liquid. Or some kind of alcohol, you want to add a little bit of whiskey to your cookies, you want to add some orange juice. That counts as liquid. Add that instead of whatever liquid you're using. If that's milk or egg whites, just replace it. If you want to add something that is fat-based, like some kind of nut butter, almond butter or peanut butter or pistachio butter or tahini, that's all 100% fat. Just replace a little bit of your butter with that and you'll get that flavor. And you'll also get that really nice color. Like one of the things I like to do to get super colorful cookies is make some of them with pistachio butter. That has like this really nice green to it. Or I replace some of the liquid with raspberry extract. Not extract, raspberry juice. And then it makes it pink. You can add lemon zest or orange zest or anything, or vanilla extract. You can replace the sugar with maple syrup because it's still sugar, it counts as sugar. Just replace with maple syrup and you'll have like this maple flavor to your cookies. And you can also add solid additions like chocolate chips, like chopped nuts, like raisins. If you add those, you just want to add those at the end so they don't tear apart the dough. Just add them at the end, just mix them in, and they're there. You don't need to replace anything with them. Now you understand that, talk about the fact that they don't even have to be sweet cookies because butter and flour is very neutral. The sugar doesn't do anything other than flavor, so we don't have to make them sweet cookies either. You can add pesto and make them pesto flavored cookies. They come out green and gorgeous. You can cook some peppers or add tomato paste and make it red. You can cook peppers and grind them into a paste and add that with some feta cheese or Parmesan cheese or any kind of cheese you like. You can add spices. You can add cinnamon or ginger. If you're making savory cookies, you can add paprika, which is really cool. It also makes like really red and awesome. You can do pretty much anything. A personal tip is you can make as many different types of cookies you want in the same bowl. You don't even have to wash it in between. My tip would be to start with the lighter colored and flavored cookies and make that batch, put it in the fridge, then make the next one that's a little bit darker or with stronger flavor, then put that in the fridge. Because then it doesn't get mixed up in a way that mixes up the flavors. Like I'll start with simple vanilla cookies, then I'll make coffee flavored cookies, then I'll make chocolate flavored cookies because the chocolate ones are the darkest. So if I have leftovers on the bowl, I don't want to get them mixed up into the next batch. And that way I make like 5 different types of cookies in one go, in one bowl, in 20 minutes. And you can experiment, you can do whatever you want with them. Here I really wanted to either have a live demo, but I'm not using my own house, so I don't have the materials in my kitchen. And I am a much better baker than I am a photographer. So the pictures of my cookies are not as pretty as those random ones I found on Google search. So you'll have to just trust me. Then you can also match it for your dietary restrictions. If you can't have sugar, you can replace the sugar with whichever substitute you like best. If you can't have dairy, like I said, you don't have to use butter. Coconut oil is magic. If you can't eat gluten, you can use gluten-free flour. I'll just say that any kind of pastry does need a little bit of gluten to hold it together. These cookies still have gluten. So gluten-free flour will give a much more crumbly cookies that won't hold together as well. That's just the downside of using gluten-free flour. There are ways to improve that, but I'm not really an expert on that, so I can't really say much other than that. So yeah, I can keep talking about cookies for like 3 more hours, but I think that's our time. So I'll open it up to questions from anyone.
Yeah, so you have some time for questions. The first question we had, there's lots of cookie questions. People were amazed and awed and a little overwhelmed with CET, but they want to know how long cookie dough stores in the fridge.
Oh, in the fridge, it stores up to 3 days, and in the freezer, up to 3 months. And you can also put it in the freezer for as long as you want, up to 3 months, and as a disc or something, and then move it to the fridge for 6 to 12 hours. And then you can roll it and do whatever you want with it. For example, use it as pie dough.
Perfect, thank you. A bunch of people want to know a little bit more about making whiskey or bourbon cookies because you brought them up and they're really excited about them. Can you give them a few tips on that?
Yes, absolutely. If you're going to add alcohol to cookies, you really don't need much. If you use too much, the alcohol might mess up the ratios a little bit. You want to add, if you're using, let's say, 100, 150 grams of flour, you want to have probably up to 2 spoons of alcohol. You want to use that instead of liquid because alcohol is still mostly liquid. After you bake the cookies, there shouldn't be any alcohol left in them because we do bake them in pretty high temperatures, around 170 degrees Celsius. I do not know how much that is in Fahrenheit. And try using alcohol with slightly stronger flavor than you would drink normally. Alcohol, like bourbons or whiskeys that are very smooth, the flavor will probably get a lot lighter inside the cookie. So you do want to use either a little bit more or a little bit stronger flavor than you would drink.
Thank you so much.
And a personal tip, it works it's a bit counterintuitive, it works great with coffee flavor.
Wow, I never would have guessed. We have a CET question. It's kind of a broad one, so maybe you can take a crack at it. It's how effective do you think it'll really be at dealing with recent past Windows exploits?
But my answer to that is going to be a tiny little bit cynical. It can be very effective if it's enabled, but I don't really see it being generally enabled by default on Windows builds anytime soon. First, no one has the processor yet, it's newly shipped, but also Microsoft has a tendency to not enable new mitigations for a long time and not enforce them. You still see applications running out there without stuff like ASLR, which have been around for 12, 15 years at this point. So I think it will be a pretty long time until we see an actual effect there, until people update their system, people update their processors, and Microsoft actually starts enforcing the use of that.
That's certainly the very pragmatic answer. I think that's all the questions we have. I want to thank you again for giving 2 amazing talks in a short amount of time.
Thank you so much for having me. It's super fun, it's an awesome conference, and I'll be around Slack on and off during the day. Feel free to ask me questions on Slack or Twitter or any other medium where you can find me.
Perfect.
Thank you so much.